Hey my dear warriors, welcome to the final session of your CBSE board physics preparation. And today I'm going to give you the most awaited sure shot physics questions for your upcoming CBSE 2023 examination. So I hope you guys are all excited because this is one of the most favorite session for all the students who are subscribed onto this channel. So let's begin the class with me, your captain, your guide, your friend, your navigator on the channel who has been teaching consistently. And I'm really proud to say this, that so many of my kids are doing extremely well in life. And I know this year, 2023, is going to be your year. So let's get started. And if you want to be my friend, you can be my friend on Instagram on this handle, captain_Shreyas. Smash the like button, of course. Tag along with your friends, your cousins, your batchmates. Let's enjoy this moment, guys. Let's not be negative. Let's not, crib. Oh my God, I did not do this portion. Oh my God, sir, I am scared about that topic. Let's be positive. Let's all work together. Let's enjoy these studies because this time is not going to come back, guys. Enjoy each and every moment of your board exam. Don't take so much of stress because Shreyas sir is here. Don't have to worry about anything. Smash the subscribe button because now we're going to begin the class. Are you ready, guys? Looks like everybody's ready with full of josh and full of energy. Hello Arutan, Rakesh, Bharat, Abdul, Darshan, Perfecto, Sugneshwar. Hello Aishwarya, hello Abdul, hello Marvel fan, Natrajan. Welcome Pranal, welcome Draw and Draw. Welcome Suji Mama, Imperial Gamer. Hello Nandini, Prachi, Logan. Good to see all of you out here. And here comes the first question on your screen. There we go. What happens to the focal length of a convex lens when it is immersed in water? When you immerse a convex lens in water, what do you think happens to the focal length? Now we know that in air, what happens is the rays will probably meet over here after refraction. So this is your focal point. This is in air. This is in air. But the same convex lens, when placed in a medium, things change because the relative refractive index reduces. Relative to outside, it is less. Earlier it was higher, now it will become less, relative refractive index. So what you will see is the rays which were supposed to meet here, they will probably meet here. So the focal length in some medium, like let's say for example it's water, it will be more. The focal point has shifted. So focal length increases. If you talk about the power is basically 1 by focal length. If focal length increases, the power reduces. This is the way you can explain it using diagrams. You can also say that the refractive index relatively reduces. So the mu relative reduces. That's the thing which you're going to say. So it refracts less. Hence the focal length shifts away. Is that okay? Yep. Does it necessarily become diverging? Well, it depends on the material of the lens. So there is one more thing that you need to pay attention to. If you can mention this also, if the refractive index of the medium is more than the refractive index of the lens, then from converging it will turn into diverging. That is also something which you can mention as a note. Is that understood? Yes, Sajita, I will tell you everything, but for now concentrate on the class and the questions. So you can mention both these pointers, that if the focal length, if the refractive index is not very high, then the relative refractive index will be such that only the focal length will increase, that's it. But if it is too highly refractive, then it will go from converging to diverging. Okay, these are the pointers. Moving on to the next question coming up on your screen. A 12 microfarad capacitor is connected to 50 volt battery. How much energy is stored in the capacitor? What happens if a slab is added when battery is connected and battery is disconnected? Beautiful question. Okay, let's try to understand this. So you can also draw diagrams so that it adds value to your problem solving. So you have a capacitor of 12 microfarad and you have a battery of basically 50 volts. So what is the initial energy stored? I can use half capacitance into the voltage square. Capacitance is nothing but 12 micro into voltage. Voltage is nothing but 50, so 50 square. So 12 by 2 is basically 6. 5 square is 25, and this 2 zeros, so 10 to the power 2, and this micro will have 10 to the power minus 6, guys. So 25 into 6, that's 150, and this will become 10 to the power minus 4. So if you want, you can just write it as 1.5 into 10 to the power minus 6 joules, or basically 1.5 microjoules. So that will be the energy stored. Just check this out. The next thing that you're going to do is, what will happen when the battery is connected and when the battery is disconnected? So for these two cases, observe this. First case, this is the first case, when the battery is connected. Now, when you add some material, then what will happen? The capacitance will increase 4 times. Capacitance will increase 4 times, yes or no? So because of that, what will happen? Think about it. If you look at the final energy in this particular case, I can say it is half. Capacitance, voltage will remain the same. Voltage will still remain the same. It will be a constant because the battery is still connected. So if capacitance increases 4 times, what will happen to the energy? That will also increase 4 times, yes or no? That will also increase 4 times. Yes or no, guys? Everyone with me? Awesome, awesome, awesome. Now, next thing that you need to do, is for the case when the battery is disconnected. For the case when battery is disconnected, what will you do? You will just say that this capacitor is now not connected to this battery. That means the charge will remain the same. Think about it. But the capacitance will still increase 4 times. So now I will not use this formula. I will use basically half q square by c. Half q square by c. Yes or no, guys? So now think about it. Capacitance has changed, but charge has not changed. So if capacitance increases 4 times, then what will happen to the energy, guys? Think about it. It will become 1 by 4 times. So basically, in the connected case, it increases 4 times, whereas in the disconnected case, it reduces by 4 times. Oh, okay. Thank you for pointing it out. Thank you. So the final answer is coming out to be how much, guys? It's 10 to the power minus 15 millijoules. Okay. Thank you for putting it up. So it was basically 1.5 into 10 to the power minus 8, I guess. All right, somewhere around that. Yep. 1.5 into 10 to the power minus 8. Yeah. Okay. Great. Cool. All right. So moving on to the next question coming up on your screen. Yep. Moving on to the next one. Yes, it will be useful for the It will be useful for the EMSAT exam also, definitely. Draw a plot showing the variation of the de Broglie wavelength of the electron as a function of its kinetic energy. How will de Broglie wavelength change as a function of its kinetic energy? And what is the ratio of the de Broglie wavelength for proton and deuteron with the same kinetic energy? Okay, so how is de Broglie wavelength related to kinetic energy? Think about it. De Broglie wavelength is the Planck's constant by momentum. But momentum, actually speaking, is root of 2 times mass times the kinetic energy. So now you can clearly see what is the clear-cut relationship between wavelength and the de Broglie wavelength and the kinetic energy. The wavelength is inversely proportional to the root of the kinetic energy. So if I were to draw a graph of wavelength versus the kinetic energy, think logically. If kinetic energy increases, wavelength decreases. If kinetic energy decreases, the wavelength increases. So it is inversely related to each other. So hence the graph should be something like this. Everyone with me? Yep, very good. Now the next point, at what is the ratio of the de Broglie wavelength for proton and deuteron? Now proton means, if you take the mass as m, the charge is basically E. For deuteron, it's basically 1 proton and 1 neutron. So the mass will be 2m, charge will be still E only. Deuteron is nothing but one proton and one neutron. That's all. So the mass will be double because proton and neutron roughly have the same mass. So if I take the de Broglie wavelength of proton and deuteron, it will be inversely related to the mass of the deuteron and the mass of the proton, of course. So mass of the proton will come over here. So this will be root of 2m divided by m. So it will be basically root 2:1. So that will be the answer for the second part of the question. Second part of the question. Yep. So root function does not change the graph. No. It will be almost similar to 1 by lambda. See guys, understand, if I have 1 by x as the function and 1 by root of x as the function. So what will be the difference? It will look very similar. But if you put it on the same graph, there will be a small difference in the curvature. That's all. But it will look curved and it will be like this only. It will be like this only. But just that the shape will be similar, the sizes, the curvature will be slightly different. That's all. Okay? Let's go on to the next one. Everyone done with this question? Can we go to the next one? Yes, you can expect these kind of questions, bacha. Yep. Moving on to the next one. Coming up on your screen. A LED is constructed from a PN junction based diode and on a certain semiconducting material whose energy gap is 3.1 electron volt. Find the wavelength of the emitted light. Although this question looks like this is an application of diode, trust me, this has got nothing much to do with that. It's all about understanding the energy of the photon and the band gap energy difference. That's all. Expect these kind of questions. So if there is a LED which is constructed and imagine the band gap is 3.1 electron volt, what is the wavelength of the light emitted? So think about it. If the energy gap is converted into the energy of the photon, from that I can find the wavelength of the light. From that I can find the wavelength of the light. So this is that gap energy. When it jumps, when it transits, that is converted into the energy of the photon. So what is that band gap energy? It is 3.1 electron volt. Now the energy of the photon is given by hc by lambda. You can also use, instead of hc, you can also use 1240 by lambda. Remember, this is also a formula in electron volt provided lambda is in nanometers. This is also a simplified formula. So what you will do is put 1240 over here and just put lambda over here. The answer, everything is in electron volts because this is an electron volt, this is an electron volt. It matches perfectly. So lambda will be 1240 divided by 3.1. You can see 124 and I can put 31 over here. This is 10. This is 10 to the power minus 1. This goes 4 times, right? This goes 4 times with it. So that will make it 400 nanometer. So that should be the wavelength of the light coming out of it. Very good. LED is deleted, but this concept is not deleted. The concept is energy gap converted into a photon. This is energy conservation, energy of photon is there and band gap is also there. So this can come, guys. Understand? Okay? So be careful. This can even come in case studies. So don't think that, sir, because this word LED is there, so it should not be there. No, it's not like that. Moving on to the next question coming up on your screen. Here it is. Draw the electric field lines for uniformly charged hollow cylinder, electric dipole, and charge is there outside a conducting shell. All right, let's have a look at it. First of all, if you have a charged conducting cylinder, then what will happen? The field lines uniformly which is there, the field lines will go everywhere outside, number one. Nothing will be there inside, so E inside will be 0, you can say that, or you can just avoid showing that over there. Mainly, you will see that the field lines will come out radially outside on this side also, and some of the field lines will also come from here because the flat surfaces are also charged. But as you go towards the end, the field lines begin to curve, you can say that. The field lines begin to bend like this. The field lines begin to bend as you go towards the edges. So it will bend at the edges, but somewhere here or somewhere here or somewhere here, the field lines will be almost straight lines. So that is how the field lines will look like. Exactly. So you need to mention this also. Many people miss this part. They only show this and this. They show radially outwards, but they forget that even the bases are charged. You can see that over here. So you need to show these field lines as well. Now for the electric dipole, positive charge, negative charge. Electric field lines should always start from the positive charge and go towards the negative charge. Start from positive, go towards negative. So just keep on showing these lines like this. That should be good enough, and you can show probably few lines just going like that. It comes after a long turn. So make sure that you show the arrow marks also. If you miss the arrow marks, then you will get less marks. Don't miss the arrow marks. Those are very, very important. Great. So arrow marks, and also show equal number of lines coming out and entering inside the negative charge. Now for the third part, where you have a conducting shell and a charge outside of it. So let's say this is a conducting shell and there is a charge over here. Let's say a positive charge over here. Example. So what will happen, because it is a conductor, there will be an induced charge, yes or no? There will be an induced charge. So do not forget to show some of the induced charges here, and the equal amount of positive charge will be induced on the other side. So these are basically your induced charges because of the pull, because of the pull of that external charge which is there, because of the pull of that external charge which is there on this side. So hence then the field lines will look something like this. Some field lines will go over here, some field lines will go here, some field lines will go here, some field lines will go here, some field lines will just go like that, maybe. Okay, you can just show some of the field lines going like that. Okay, there is nothing to end over here because these are positive charges. So from here also you will get some positive charges like this. You will get outward fields like this because these are positive charges. So from positive charges, show the field lines coming out. Some of the field lines will not be able to terminate on the negative charge because not so much of negative charges are there. Only few of the negative charges will make sure that the field lines terminate. That's all. That's how it will spread. Everyone? I hope this is clear. Yep. It's not a normal cylinder. Yes, it's not a normal cylinder. Yep. So these kind of questions of drawing the field lines can come for 2 charges, 3 charges, 1 charge, 2 charge. So these conceptual drawing diagrams can come. They can also ask you draw the magnetic field lines for 2 bar magnets or just 1 bar magnet or a horseshoe magnet. So practice these field lines or at least see these field lines for magnets and electric fields. Okay. So I have put up the model solutions after every question. You can see that later on. Now 2 beams of light having intensities I and 4i interfere to produce a fringe pattern on the screen. The phase difference between the beams is pi by 2 at a point and pi at another point. What is the difference in the resultant intensity at A and B? Let's see. How many of you can do this? Come on guys. I want you guys to try it out on your own and let me know what you think is the correct answer for this. Come on, everyone think about it. Everyone think about it. Yes, the question, do you know what questions will come in the exam? I can guess, bacha, but obviously nobody can be 100% sure. So this is just by observation of the previous year papers and looking at the current trends of what they are asking. Okay, and there are hardly few topics left now because so many topics have been deleted also. So it becomes a little bit easier to guess what topics the questions can be asked from. So the formula for intensity of the resultant bacha is nothing but intensity of A plus intensity of B plus 2 times root of intensity of A, intensity of B into cos of delta phi. This is the formula that you are going to use. Now for intensity of A, it will be nothing but I plus 4i plus 2 root I into 4i into cos, the phase difference initially is pi by 2. Now cos 90 is basically 0, so it will just become I plus 4i, that means it will just become 5i. That is intensity at point A. Similarly, intensity at point B, same thing, I plus 4 times of I plus 4 times of I plus 2 into I into 4i, but this time the phase difference is pi radians. Cos of 180 is minus 1. So I plus 4i will become 5i plus 2 into 4's root will be 2. So into 2i, and this is minus 1. So this will become minus 4i and this is plus 5i. So it will just become I. So that is intensity at point B. Now the question is not that. The question is what is the difference between their intensities. So question is actually what is IA minus IB. So that would be nothing but 5i minus I, which is basically 4 times of I. So that is basically the difference of the intensities. You always have to block the answers, keep that in mind. Okay, so Krishna Vlogs, you can just go back a little bit behind and catch up. Okay, so it's very easy on YouTube. You can just go behind at any point of time, even in a live class. Okay, so this is the main formula which you should remember. This is for intensity. For amplitudes, it is A1 square plus A2 square plus 2 A1 A2 cos delta phi. Entire thing under the root is the resultant intensity. So that's a small change for amplitude. For intensity, it looks similar, but the root is only there here, not everywhere else. Yep. So moving on to the next question coming up on your screen. If there is a small current passing through a wire, uniform cross section, resistance, what is the resistivity and conductivity of the material in this particular experiment? Okay. Can we also write delta I for the difference? Yes, you can. You can, definitely. Should you see any other PYQs apart from yesterday's session? If you have time, watch it. Please do look at the other PYQs. Don't restrict yourself. See, if you have time. If you don't have time, that is okay. Great. Thank you, Malali Shah. Yes, theory questions are also going to come, Praveen Kumar. Moving on. Your diagram should be always done using pencil, bacha. Don't use pen. Okay? Use pencils. Okay. So, in this particular question, resistivity is asked, resistance is given, area is given, and length is given. So, using the formula R is equal to rho L by A, rho will be equal to resistance into area divided by length. Resistance is 5 ohms. Area is basically this 6 into 10 to the power minus 7, and the length is nothing but 15, right? So this will go 3 times, this will go 2 times, so it will be 2 into 10 to the power minus 7. So that is what the answer will be. It will be ohm meter. Ohm meter is generally the unit for resistivity. Similarly for conductivity, what is conductivity? It is 1 by resistivity, so it will be 1 by 2 into 10 to the power minus 7. So 1 by 2 is basically 0.5 into 10 to the power 7. So it will be basically 5 into 10 to the power 6. But this will be ohm inverse, meter inverse. That's it. That is the conductivity of that material. It's very, very conductive. It's very, very conductive. Yes. So these are the final answers. Very good. Awesome. Awesome. I'm coming to that, Gautam. Hold on, bacha. I'm going to do numericals also and theory also. Both. Don't worry. Yes. Do you need to write full mock test for 3 hours or just seeing is enough? I would say at least give 1 mock test. Seeing will be okay tomorrow, not today. At least give 1 mock test, bacha. The work function of tungsten is this much. The wavelength of radiation which can eject photoelectrons of maximum energy 1.5 electron volt from tungsten will be how much? Okay, so this is a question on photoelectric effect. Work function is given to me, which is basically 5.4 electron volt. What is given, I will write it down. Kinetic energy maximum is also given to me. That is basically 1.5 electron volt. Question is find the wavelength. We know using photoelectric equation, the energy of the photon is the work function plus the maximum kinetic energy. Energy of the photon is 1240 divided by lambda in nanometers. This is electron volt. Phi is work function in electron volt, so 5.4 electron volt plus kinetic energy also in electron volt, 1.5 electron volt. Now 5.4 plus 1.5 is going to be 6.9 electron volt. You can see electron volt and electron volt will just cancel. Therefore, the wavelength will be nothing but 1240 divided by 6.9. This will be in nanometers only. So just do the math and see how much is it approximately coming out to be. 124 you can approximately divide it by 7 to get a close enough answer, but in the exam you are actually going to divide it by 6.9 or basically 69 and take the appropriate powers of 10. No, these are not PYQ Shraddha. These are questions collected from our bank. Yep, close to, check it out guys, 7 ones are 7, so basically you have 554, yeah, almost basically 18, so almost close to 180 nanometers. Almost close to 180 nanometers. The exact value comes out to be, yeah, 179 nanometers. So the exact value comes out to be 179 nanometers, which is also 1790 Angstroms. Okay, if you want to keep it in Armstrong, you can keep it in Armstrong. This is also fine. This is also fine, bacha. This is also fine. That is also fine. Both are okay. Is that understood? Can you round off 6.9 to 7? Shraddha, that would be okay if it was a JEE Mains exam, but this is a board exam. So they would expect you to give the answers in a better way, rather more accurate way. So please do not convert it into 7. That will be okay to just verify, are you doing your mathematics correct, or is your answer close to whatever you are expecting? Only to verify it is okay, but final answer, please do not write it by dividing it by 7, okay? Don't round off. All right, moving on to the next question. Yep. Practicing back book is not sufficient, bacha. Okay, so moving on to the next one. What is the transition corresponding to the longest and the shortest wavelength in the Balmer series? Okay, so this kind of theory question can also come, and when it comes for, let's say, 2 marks, or maybe it can even come for 1 mark. If it is for 1 mark, you can directly mention the answer, but if it comes for 2 marks, then I think you should better explain it with a diagram. That will be good. So this is n is equal to 1, this is 2, this is 3, this is 4, and you will have infinity on the top. So if you want the shortest and the longest wavelength, guys. So first, for the longest example, when wavelength is large, frequency is less, energy is less, so the gap will be also less. So for Balmer series, you have to go from here to here. This will have the longest wavelength. So for longest, what will happen is, if you want longest wavelength, that means you want the smallest energy gap. So hence the answer will be from 3 to 2. This is not Lyman, this is Balmer. Exactly. Similarly, for the shortest wavelength, you will want the large energy. So maximum energy gap. Now why am I saying this? Because I know that energy is hc by lambda. If lambda is more, energy is less. If lambda is less, energy is more. That is the reason for that. So for that to happen, it should come from infinity to here. That is the maximum gap you can get. So from infinity to 2 will be the shortest wavelength. Exactly. Perfecto. Everyone with me? Everyone with me understood how to write the answers? If it is for 2 marks, or if it is for 1 mark, you will directly mention this is this, this is this. That's it. That's all. So check the marks and accordingly choose the length of your answer. Okay. Moving on to the next one, coming up on your screen. What is the significance of the negative sign in the expression energy is minus 13.6 by n square electron volt? Come on, everybody should write this answer, guys. I want everybody to recollect from the chapter of atoms and atomic structure. What was the reason of putting that negative sign in the energy expression? So when you write energy is basically negative 13.6 by n square electron volt, this minus sign signifies that the electron is bound to the nucleus in the atom. That's number 1. Also, it signifies that energy must be provided to set the electron free, that is till infinity. So they are bonded. Very good. Electron is bound to the nucleus inside that atom. And also mention one more point, that if you need to set it free, then you need to provide energy. So from negative, you make it free, that means you go to 0 energy state at infinite when n tends to infinity. So when n tends to infinity basically. So as n tends to infinity, the energy tends to 0. So just mention this. That is more than enough. You will get full marks for this particular question. Understood? Moving on to the next one coming up on your screen. 2 metallic spheres, same radius, one solid, one hollow, are same potential. Then which one do you think will hold more charge? I want you to answer this question, okay, in 1 line maybe or 2 lines in the chat box. Looking at it, looking at all your chats, guys. Is NCERT questions enough? Not enough, bacha. You have to look at PYQs. Is only PYQs enough? No, obviously not. You have to look at both. You cannot just skip one thing or the other. Okay? Come on. Answer the question, guys, quickly. What is the answer? Yep, I will give you the derivations, definitely. Some people are saying solid, some people are saying hollow. Divya is saying same. Well, let me tell you guys, be it hollow, be it solid. This is solid, this is hollow. What will happen to the charge? It's a conducting shell, right? These are metals. So if they are metals, what will happen? The charges are going to be only there on the surface. They are only going to be there on the surface, nowhere else, right? They are going to be there only on the surface. They will not be in the bulk. So the behavior is exactly the same. Charges are there on the surface. So if you write the potential here, it will be kq by r. Here also it will be kq divided by r only of the solid sphere. So it does not matter. In fact, both are at the same voltage. If both are going to be at this, they would have the same formula for the voltage. Because of that, you can also say this charge must be same. If the voltages are same, formulas are same, charges should also be the same. So yes, the answer is same. Understand that. So basically charges on the surface, they behave exactly like the other one. So the potentials being same, the formula being same, you can also say that the charge is going to be the same. That is the answer. That's it. Great. Hollow will have two surfaces. Balaji, very good. But tell me one thing. In those two surfaces, where does the charge stay? When you have a hollow shell, the charges are only going to be there on the outer surface. It is never going to be there on the inner surface. Remember, always charges go on the outermost surface. Outermost surface. So there is zero charge over here on the inner part of the shell. Understood? Yep. I hope this is clear. Moving on to the next one coming up on your screen. Filaments of 60 watts and 100 watts bulbs are of the same length. Which filament will be thicker? So this give reason kind of questions can also come. This give reason kind of questions. Induced charges. Why do you want induced charges? It's a isolated sphere, Kirtana. One separate solid sphere, one separate hollow sphere. So there is no question of induced charges. Okay. So Karthik, watch my lecture on how to score full marks for physics. Just check that out. Okay. So moving on now, guys, for this question. Power of a bulb is V square by resistance. So resistance is basically V square by P. That's one formula I will need. And for the filament size, I will use this formula. Resistance is rho L by A. Now imagine if I talk about the bulb which is of higher wattage, that means if the wattage is higher, the resistance is lower. Wattage is higher, resistance is lower. So if resistance is lower, length is same, resistivity is same. So obviously the denominator should be higher. What does this tell you? Clearly, if power is more, then the area is also higher. So which one will have higher cross section? It's obviously 100 watt. So 100 watt is basically going to be thicker in the cross section. Definitely it will be having a thicker cross section. So you're going to block this or highlight this or underline this. So that is the final answer. Very good. Awesomeness. If you got 100 as the answer, I hope you get 100 marks even in the CBSE board examination. Moving on to the next one. But the reasoning is very important. Don't miss writing these formulas. And here I have just put arrow marks. Don't do this in the exam. Write it properly. If the power increases, then the resistance will be less. If the resistance is less, then the area is more as per the formula. Hence, the more power, the area will be also higher. Hence, 100 watt has higher area of cross section or thicker cross section. That's how you're going to write it in words. Don't just put symbols over here. Moving on. Thank you, Bharat Krishna. Thank you. Great. Kirti Kumar MGK is saying, can you do this for maths also? Guys, do you want me to teach maths for boards? Do you want me to do some sample paper or PYQs or Sureshot for maths? You want me to? Akka, you learn. Let's do it. Shreyas sir, the all-rounder. Already I'm doing English also. I took English paper. Then I took your BitSat logic test. This year also I'm going to do logic test. Now physics so anyways I'm doing. Now you want me to do maths also. Yeah, let's do it. Okay, let's see. I'll try. Okay, let's see if things work out, and because I have to manage other things also apart from my physics lectures, let's see if I can take my time out and do these things. I'll definitely make an effort, bacha. Circular coil and current I, radius R and number of turns N. If all three are doubled, what do you think will be the change in the magnetic field at the center? Computer also, wow. So the magnetic field at the center of a coil is given by mu naught current by 2R, but if there are N turns, you put N over here. That's right. Now see what will happen. If you have a new coil with more turns, more current, more radius, in fact double. So for the new one, what will happen, guys? It will be mu naught current into 2 and number of turns into 2 divided by 2 into R into 2. This 2 cancels, only this 2 is remaining. So 2 into mu naught I by 2R. Mu naught I by 2R, or rather this N is also there. Mu naught IN by 2R is this original magnetic field. So it will become 2 into the magnetic field of that original coil. So the new field will be basically 2 times. So you're going to mention this word 2 times in the final answer. The magnetic field increases 2 times as compared to the old one. Very good if you marked it as 2. Awesome. Great. Here is the next question. This is an assertion reason type. Let's see if you guys can solve this. According to electromagnetic theory, an accelerated particle continuously emits radiation. According to classical theory, the path of an electron in Rutherford's model of an atom is parabolic. What do you think? Is this explaining the assertion? Do you think both are correct or one of them is wrong? Come on, think about it and answer. Yes, Bacha, Vijay, watch all my sessions for board examinations. Just don't watch today's session. Watch previous session also. A lot of you are saying C, some of you said B. Well, I feel that the correct answer is C. You can see that assertion is true, but the reasoning is going to be false. Now, why is that correct? Observe. According to EM wave theory, an accelerated particle continuously emits radiation. That is correct, guys. If you take an electron and if you accelerate it, there will be definitely some electromagnetic radiation, and because of that, it will lose its energy. That is the drawback of Rutherford's model, which was overcome by Bohr. Remember, according to Rutherford, the electron will fall into the nucleus, but that does not happen. So Bohr explained it by stationary orbits. Now, according to classical theory, proposed path of an electron in Rutherford model will be parabolic. What nonsense! If you look at the electron's path, it is not parabolic, guys. In fact, it is circular. It is circular. It revolves around the nucleus. So in a circular path, circular orbits, he did not mention why these orbits are going to be stable or stationary, but it will definitely go in circular orbits because of the centripetal force acting on it. So the nucleus will be at the center. So parabolic word is used. Obviously, this word is wrong. That's it. Awesome. Great. So that is the answer for this. Moving on to the next one. Coming up on your screen, but that is what Rutherford thought it will be circular, but then see other scientists said that listen, your model is wrong. According to your model, you are saying that it will be circular, but actually it will not even be circular because it will lose energy. It will end up going inside the nucleus. It will destroy that atom. So that's what other people said after Rutherford, and then Bohr came and said, okay, I know why it is not falling inside the nucleus. Moving on to the next question. What do we have? Average thermal velocity of the electrons in a conductor is 0. The direction of the motion of the electrons are randomly oriented. Is that true? False? Explaining? Not explaining. No, it is not elliptical, bacha. It's not doing Kepler's laws. So, yeah, he did not use Kepler's laws and all, elliptical and law of time periods, all that he did not say. Option A, is that right? Perfect. I think you guys should be correct. Yes, option A is the correct answer. We know that inside a conductor, the electrons keep moving randomly here and there. Each electron keeps moving randomly here and there. So because of that, what happens is that the average velocity becomes 0. So only because they are randomly oriented, one here, one here, one here, one here, one there, one here. So average comes out to be 0. Definitely. That's the average thermal velocity because of the collisions. Because of the thermal collisions. Definitely. This is correct answer and it is also the correct explanation also. Moving on to the next one. A convex mirror is preferred over a plane mirror in vehicles to observe traffic coming from behind. The reasoning says image formed by convex mirrors are erect, they are diminished in size and also has a larger field of view. Is that right or wrong? What do you guys say? Awesome, Vedantu JEE lover. So glad. A lot of you are saying option A. Is that right or wrong? Yes, there is a good chance that these questions will come. Many of you are saying A, some of you said C also. I don't think this is false, guys. This is correct. Yep. Why? A convex mirror always forms a diminished and erect image, right? So convex mirror, always the image is diminished. It is also virtual and also what happens? It is erect. So definitely these characteristics are correct. And because many things are there behind you, all these things become small and everything is put on your mirror. So you can see a lot of things in a small area. So the field of view increases. So you are seeing many things in a small area. Field of view, that is. So field of view is larger, correct. That is why you prefer a convex mirror over a plane mirror. Understood? Great. No, Srihari, it is not real, bacha. This is virtual. Real is there in concave mirror. Be careful. Concave or in concave, the images can be even virtual. It can be even real. It depends. It depends where you are placing the object. So, but for convex, it's always going to be virtual. Keep that in mind. Moving on, we have a theory-based question. Let's see if you guys can answer this. Carbon, silicon, germanium have same, atomic structure, lattice structure. They bond very similarly. But have you ever thought why carbon is an insulator, whereas silicon, germanium are intrinsic semiconductors? Come on, guys. If you look at the periodic table, also carbon comes over here. Then you have silicon, then you have germanium, then you have tungsten, right? This is how your periodic table works. Okay, so why is this a semiconductor? Why is this a semiconductor? Whereas this is basically like an insulator. You will never see carbon as a semiconductor also. You'll always see carbon fiber, carbon things being used as an insulator. The reason for that is, in case of silicon and germanium, the electrons which are on the outermost shell, think about those electrons as compared to the ones in carbon. In carbon, if this is the nucleus, okay, the electrons are very close to the nucleus in case of carbon. Whereas if you talk about silicon or germanium, what will happen is, if this is the nucleus, first orbit, second orbit, third orbit, so like that, you will see that the subshells, the shells will be more in number. The transitions that have to happen to go into the conduction band are going to be easier because you are away from this guy. You are away from the nucleus. Because it is going to be easier, that means that the energy gap is going to be less. So the energy gap to go from valence band to conduction band is less. And in fact, it is less than 3 electron volt. Hence, it is a semiconductor. Whereas for a carbon, it is very close to the nucleus. Nucleus will not let that electron jump. It is very difficult to go. It is difficult for it to go. In fact, that energy gap is more than 3 electron volt. Hence, it is an insulator. That's how you're going to mention it. Understood, guys? If you mention this, that's it, you will get full marks, or else you will not. Moving on to the next one, coming up on your screen. 2-point charges, 4 and 6, repel each other. Force of 12 Newton. If each one of them is given this much charge, what will be the new force of attraction or repulsion between them? Yes, it is an example question and that can be asked also. Definitely, you can watch all the one-shots, and also if you are using the crash course lectures, you can definitely crack it. You still have 1 month of time. Yes, it is possible, bacha. People have done it in the past. Now, the first case, the force will be some constant, okay, that Coulomb's constant, into charge 1 into charge 2 divided by r square. Whereas in the second case, what will happen is Coulomb's constant, the new charges will be slightly different. You are adding -5. So guys, 4 plus -5 will become -1, and 6 plus -5 will just become +1. So the charges will now be -1 into 1 and divided by r square. Now divide both of them. You will get F2 divided by F1. K, R gets cancelled. What you will have is -1 divided by 4 into 6, which is -1 by 24. So F2 will be F1 by 24 with a negative sign. So minus force in the first case was 12 Newton. So minus 12 by 24. Hence, the new force will be minus 0.5 Newton. You can say the magnitude of the force is 0.5 Newton. Earlier it was repulsive, and now it is negative. That means it is attractive. So I can just say it is attractive in nature. So you can mention this like this. Either mention this or this. To be on the safer side, mention this also, so that the teacher is very, very clear. Exactly. So that's how you are going to mention the answers. Okay, be very clear in your answer sheet. Mention this also. Just don't directly write this. Okay, mention why the new charges are -1 and +1. Mention all that. Moving on to the next one. How much current is drawn by the primary coil of a transformer connected to 220 volt supply when it delivers power of 110 volts and to a 550 watt refrigerator? So we have basically a transformer. We have a transformer connected to a refrigerator. The input voltage of the transformer is connected to 220 volts. The output is at 110 volts. Power is basically 550 watts for the refrigerator. This is the symbolic diagram just to give you a perspective of what is happening in the problem. That's all. So now think about it. In a transformer, the losses are generally negligible. The efficiency is close to 100% for most of the transformers. For most of the transformers, the losses are considered negligible. So because of that, the input power will be equal to the output power. But output power is basically 550. So that should be also equal to the input power. Great. Now we all know that power is nothing but voltage into the current. So here the power is 550. Voltage in the input side is 220 because the current is asked. In the primary coil, so I'm just going to put IP over here. Input voltage into input current is that input power. So 0 cancels. IP will be 55 by 22, goes with 11 5 times, and this will become 2. So current will be 2.5 amperes. 2.5 amperes. Some of you got it. Very good. Kirtana, Vasant, Vimal, Prachi, Sriyari, Balaji. Very good. Mohit, Rishin, Shraddha. Awesomeness, guys. This is the final answer. So you might be wondering, sir, what is the use of 110? A lot of students will get confused. What is the use of 110, guys? Come on, put it in the chat box. What is the use of 110 volts? Exactly, Justin. Chumma, man. Waste it is. Nothing. No use. No use. In this problem, it's of no use. Exactly. It's a waste, fellow. Yeah. To confuse you. Very good. Yeah. But if they ask you what kind of transformer or what is the turns ratio, then it will be useful. For now, it is not there. Now there is no use. If they ask you what type of transformer, voltage is reducing, so step down. Turns ratio, this will be 2, this will be 1, 2:1. So for that purpose it can be used, but right now in this problem, no use. Moving on to the next question. When an AC source is connected through across an inductor, show on a graph, write the equation of variation of voltage and the current over one complete cycle. Okay, this kind of theory question can also come. Yep. So secondary by primary, you can mention that secondary by primary will be 1:2, primary by secondary will be 2:1. So you can mention that better, Kirtana. Okay, so on the safer side, because if the teacher interprets it in a different way, that will be a problem. So mention secondary to primary is this, or primary to secondary is this. Okay, great. Moving on to this question. When you have an inductor, first of all, show this diagram because it's a theory based question and it is connected to an AC source. There is no resistance. Okay, fair enough. So this is my inductor. Now we know that in an inductor what happens is the current, if I show it in the horizontal direction, the voltage is like that. This is the voltage across the inductor, assuming the phasor diagram is rotating like this. Now if I show the graph of the variation of voltage and current, this is how it should look like. Observe carefully. Observe carefully. I can just say that this is time. This is time. The voltage, I can just say that it is probably going like this. Okay, I can just say it is going like this. Whereas the current will be like this. This is the current and this is the voltage. If you notice carefully, the voltage is already ahead of the current. Voltage is ahead by pi by 2 radians as compared to the current. It is already gone on the top. Current goes on the top later on. Voltage is leading. You can see voltage is ahead of the current. These rotate like this. Voltage is already in front. Current is following the voltage. Definitely. If you look at the equations, this is how it should look like. If I write current equation, it will be I naught sine omega t. Okay, I can use a sine function, I can use cosine function, does not matter, guys. Whereas for the voltage across the inductor, it will be maximum voltage across the inductor, max voltage across the inductor into, here if I use sine, I will use sine only, but because voltage is ahead of the current, I will put sine omega t plus pi by 2. That is very important because it is ahead by pi by 2. So that plus pi by 2 is important. This is one option. You can also write it as, I'll just put an or over here, or you can also put V is equal to V max L. You can put sine omega t here. Then the current will be I naught or I max. Here I will put sine omega t minus pi by 2. Don't put both the answers, but both the answers are correct. Both the answers are correct. Understand that. Okay? Either you write V as sine or I as sine. Accordingly, adjust the other equation. If you write I as sine, then voltage is ahead. So put plus pi by 2 for voltage. If you write voltage as sine, then current is behind. So put minus pi by 2 with current. That's all. Is that understood, bacha? Can we write IV cos pi by 2? No, Kishore. Write it like this only. This is the correct answer. Same kind of question can also come for capacitor. Same kind of question can also come for LCR circuit. Just explain LCR circuit. What is a phasor diagram? So you should be very well versed with the phasor diagram, the equations, the graphs, and the circuit. So show all the 4 things. If it is a 4-mark question, you might have to even derive it. If it is a 3-mark question, I think these 2 things is more than enough to get you 3 marks. Alright, moving on to the next one coming up on your screen. In ray optics, it's a theory based question. It's based on the assumption that light travels in a straight line. Diffraction effects disproves this assumption. What assumption? The assumption that light travels in a straight line. Diffraction says that is not correct. Yet ray optics is commonly used in understanding where the image is formed and many other properties of the image in optical instruments. What is the justification for that? Yep, come on, think about this. What is the justification? I am waiting to hear your answer. You can pakka write down the whatever sentences in the chat box. You can definitely put it up in few words so that I get to know, others get to know what you guys are thinking. Okay, think about it. Okay, some of you are saying, sir, wavelength is not of the order of the optical instruments. Conditions were small, patterns, there is no obstruction, direction of propagation of light wave, diffraction, the order of wavelength of light, whereas in ray optics, it's more than the wavelength of light. Somewhere close, few people are hitting close to that nail, but not directly on the nail. Guys, yeah, the correct word over here is basically the diffraction. The diffraction effects happen when the wavelengths are close to the size of the obstruction or the aperture. So here, aperture, which is the opening or the slits which are there, are wide enough to basically create minimal diffraction. So what happens is, because of that, because they are so wide, you will see there is minimum or very less diffraction effects. Diffraction means spreading of light. So there is hardly any spread. So the light which was supposed to go will keep traveling in the same direction. It will not spread so much. So you will see that the light will just keep on traveling almost in straight line. Else the light would have spread. So that is why in optical instruments, you use the concepts of ray optics. You use the concepts of ray optics because there is negligible spreading. The apertures, the slits, the openings are very, very wide. So the wavelength will not get diffracted for such a big opening, because only if the wavelength is close to the size of the aperture, you will see diffraction effects are dominating. Here, it's big, wavelengths are very small. It's very, very small, so it will not get diffracted. Okay, moving on to the next question coming up on your screen. Yep. So once again, all right, I'll just explain this to you once more. Okay, guys, only if wavelengths are close to the size of aperture, only if it is close enough, then diffraction or basically spreading occurs. Then spreading basically occurs. But the optical instrument sizes, the lens size, the mirror size, everything is big, 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 big. So the light does not spread a lot. When light does not spread a lot, it travels in straight lines. When it travels in straight lines, that means you are using the concepts of ray optics. Ray optics means you can use geometrical principles. Light ray is going in straight line unless the medium changes. So you can use the concepts of ray optics in optical instruments because the apertures are big. Understood? Got it? That's all. No formula is needed. No formula is needed. Got it, guys? Everyone? Perfecto. Moving ahead to the next question. Great. In the following diagrams, which diodes are forward? Which diodes are reverse? Which diodes are forward? Which diodes are reverse? Come on. Look at these options. See which one do you think is forward, which of them is reverse. Here, this is 0 volts. This is 5 volts. This is at a higher potential. This is at a lower potential. So this is P, this is N. P-N junction. How can N be at high? That means it is a reverse bias. Definitely it is a reverse bias. Okay. Mark the values so that the teacher gets convinced that okay, you have solved it properly. So when you write the answers, draw this diagram, just show 0 volts and just put 5 volts. This is PN, just say it is reverse. Okay. And same thing over here, you can see this is basically high voltage. This is basically relatively lower voltage. This is P, this is N. So definitely this is going to be a forward bias. P to high, N to low. Perfect. This is -10, this is 0. 0 is obviously higher and -10 is obviously lower. This is P, this is N. Obviously this is now a reverse bias. Here this -5 is obviously higher than -12, -12 it is. This is P, this is N, guys. So P to high, low to N. This is definitely a forward bias. Definitely. Reverse, forward, reverse, forward. Perfectly arranged. This is the logic. Show the markings. You might create a better impression on the teacher by correcting your paper. So It's good always to mark certain things on the diagram. Not on the question paper, in the answer sheet, okay? Just see if it is for 3 marks or 2 marks. If it's for 1 mark, then don't do it. If it's for 1 mark, now, then directly write reverse, forward, reverse, forward. Even for 2 marks, I think you should preferably draw the markings, 2 or 3 marks. Okay, moving on to the next one. 2 identical heating wires, first connected in series and then in parallel. What is the ratio of the heat produced in both the cases? What is the ratio of the heat produced in both the cases? In the first case, when both of them are in series, then the equivalent resistance will be R plus R, which is basically 2R, correct? The power in series will be voltage square by the resistance, which is basically 2R. That's it. This is your equivalent resistance. That's in the first case. In the second case, you are connecting the heater coils or the resistive coils in parallel. So the equivalent resistance 1 by Rp is 1 by R plus 1 by R. That will give you basically R by 2. So the power in parallel will be V square by R by 2, which is basically 2V square by R. Correct? Now the question is, what is the ratio of the heat produced in both the cases? So power in series upon power in parallel. Power in series V square by 2R. Power in parallel, that is 2V square by R. V square, R cancels. So I will just have 1 by 2 into 2. That is basically 1 by 4. That is the answer. 1:4. Exactly. Perfecto. Amazing. The reason why I'm not just doing CBSE sample paper, Sachin, because already the model solutions are there. You would like to practice more problems apart from the sample paper. Number 2, I would want you guys to solve the paper on your own and yourself check what are the answers. That is better. And some of the concepts are very much similar also. That's another thing from not just this session, but also the previous few sessions that we have been doing. Next question coming up on your screen. Suppose you have a silicon crystal, these many atoms. It is doped 1 ppm, parts per million. You would have heard this term in chemistry also. And because of that pentavalent impurity, the number of electrons and the hole concentration, what do you think it will be? What do you think is the hole and the electron concentration going to be? Okay, let's try to figure this out. Okay, guys, observe now carefully that the intrinsic concentration is already mentioned as 1.5 into 10 to the power 16. And I already know Ni is squared, then you get NH into Ne. So to find both of them, I will use some given information. If I know either this or this, I can find the other. Ni I already know, which is basically 1.5 into 10 to the power 16. So I already know that. So that is going to be 2.25 into 10 to the power 32. Only thing I need to figure out is either one of them. It is clearly mentioned that you have doped by 1 ppm the pentavalent impurity. That means it is N type of semiconductor. So to find the number of electrons per unit volume, what I will do is think this way. Think about it this way. The number of electrons per unit volume. What will I do? This crystal has these many atoms per meter cube. In that you added 1 electron per million. 1 ppm means 1 electron per 10 to the power 6 atoms. 1 electron is there for 10 to the power 6 atoms. So for these many atoms, how many electrons will be there? Think about it. So if you have 1 electron for every 10 to the power 6, so how many such 10 to the power 6 units will be formed? Obviously the answer will be nothing but 5 into 10 to the power 28 atoms will be there, and divided with 10 to the power 6, divided with 10 to the power 6, that many units will be formed of 10 to the power 6 millions basically, and each unit will have one electron. So those many electrons will be there per meter cube. That's all. So hence the concentration of electrons will be nothing but 5 into 10 to the power 22 per meter cube. per meter cube. That's it. That is the first answer. Everyone with me on this? Great. Now use that data over here. NH is something which I do not know. NH is something which I do not know. The electron concentration is basically 5 into 10 to the power 22. Now to find out NH, just take this and divide it with that. So it will be 2.25 into 10 to the power 32 divided by 5 into 10 to the power 22. This would be 225 divided by 545. So this will be 0.45 into 10 to the power 10. If you want, you can just put it as 4.5 into 10 to the power 9. So that is the whole concentration that you get. 4.5 into 10 to the power 9. Yep. Great. Yeah, that's the correct answer. Understood, guys? Both these answers, you have to show the calculations. You have to also understand why I divided by 10 to the power 6. I'll just repeat it again. There is one electron for every million units or million atoms. I can take that million atoms or 10 to the power 6 atoms as 1 unit. So in these many atoms, how many such units will be formed? So you take that number and divide it by 10 to the power 6. Those many units will be there. Each unit has 1 electron. So those many electrons are there per meter cube. As simple as that. Got it? Moving on to the next one coming up on your screen. See, you asked for nucleus sums and see, nucleus sum came only here. Okay. Can you use the formula I squared RT? You can use draw and draw, but it will be much more complicated because the currents will get divided and all of that. I by 2. It's same in series. So you need to do it like that. Okay. And also it's connected across the same battery. So the currents will be different in each case. So currents will not be the same. So do not do it by I squared RT. Okay. I hope that answers Shraddha and draw and draw. Great. So for this particular question, what you can do is, question says what is the binding energy? Binding energy of a reaction is basically the binding energy of the product minus the binding energy of the reactant. This is the formula. It's always product minus reactant's binding energy. So over here, the binding energy of the product, what is the product over here? It's basically helium, right? So what is that going to be? It's just going to be 2.23. It's not 2.23, my bad. Helium is not that one. Helium is this one. It's 7.73. 7.73. Nitrogen does not have any binding energy. Neglect that. Minus reactant. There are 2 hydrogens. So 2 into 2.23. So now just do the math, guys. You will get the answer. So you have 7.73 and 2.23 into 2 is nothing but 4.46, right? So what will this become? 13 minus 6, that's going to be 7, and then this is going to be 6. This is going to be 2, my bad. This is going to be 2, and this is going to be 3. So 3.27, just check this out. So the answer will be 3.27 mega electron volt. That is the answer. That's it. Just check this out. Yep, 3.27 mega electron volt. So main thing many people make mistakes is whether it is reactant minus product or product minus reactant. So it's always the binding energy of the product, the outcome, minus the binding energy of the reactant. If you remember that formula, things are very easy. Moving on to the next question. In a half wave rectifier, the output frequency, if the input frequency is 50 Hertz, is how much? The output frequency for a full wave rectifier for the same input frequency. Simple question, guys. If you have a half wave rectifier, then the output frequency will be equal to the input frequency. So shouldn't it be still 50 Hertz only? Yes or no? That is the first part. For the second part, when it is a full wave rectifier, the output frequency is basically 2 times of the input frequency. So 2 into 50. So basically 100 Hertz. This and this are the answers. 50 and 100. Very good. It's double in case of full wave. Many people think that half wave means half. So they divide it by half and write the answer as 25. And for full wave, they think, oh, same frequency will come, and they write 50. So be careful. If you are aware of the waveforms, if you are aware of the working, if you know what the circuit looks like and how the input and the output, voltages change, you will definitely not make any mistakes. You will get the correct answer. Next question. Last few questions coming up, guys. Yep. The near point of a defective eye person, hypermetropic eye person, is 50 centimeters. What should be the power of the lens so that the person can read things clearly when it is held at 25 centimeters from the eye? So just imagine that there is an object kept over here, okay, which is supposed to be at 25 centimeters. This is an object from your eye. And you want to use a lens so that you can see it clearly. How do you make it clear? Simple. For your eye, the near point is 50 centimeter. This is much closer than what you can read or what you can see clearly. So what you do, make this object go away. Make this object go away. Make the image over here. Now if the image distance is 50 centimeter, then your eye can see things clearly. So if things are close, you bring them or you push them really far away till where you can see things clearly. That's it. Then everything will appear properly. That's the lens that you're going to make use of. So make use of 1 by V minus 1 by U is equal to 1 by F, lens formula. Image distance, it's going to be minus 50. Object distance is going to be minus 25 is equal to 1 by F. So 1 by 25 minus 1 by 50 is equal to 1 by F. So 1 by F is basically how much? 1 by 50 only. So focal length is 50 centimeters or basically 0.5 meters. But the question I think is, what is the power? So power is 1 by F. Sorry, 1 by F. 1 by F. F is always going to be in meters. So 1 by 0.5, guys. So that's going to be 2 diopters. So power is 2 diopters plus 2. So that's the answer. So because it is plus 2, what does it mean? It is what kind of a lens? It's a convex lens. Then comes the next part. Next part I will do it on the next slide if I have space. Yes. The refractive index of a substance of a prism. This can come for 4 marks, guys. 2 marks for this, 2 marks for this. Refractive index is root 2. Angle of prism 60 degrees. What is the minimum deviation for that light? Okay, let's write down whatever we know. Angle of prism 60 degree. Mu, that's root 2. Delta minimum I need to find. Which formula are we going to use? Some of you have already posted the answers. Very good, guys. The formula that I'm going to use is mu is equal to sine A plus delta minimum by 2 upon sine of A by 2. Everything here is in the given or to be found form. That's it. So refractive index root 2, sine of 60 plus delta minimum by 2 upon sine of 60 by 2. So sine of 60 plus delta minimum by 2 is equal to root 2 into sine 30. Sine 30 is half. So root 2 and root 2 will cancel. It will become 1 by root 2. Now think, whose sine is 1 by root 2? Which angle sine is 1 by root 2? Obviously 45 degrees. So hence, whatever is there inside, 60 plus delta minimum by 2 will be 45 degrees. So 60 plus delta minimum is 45 into 2 is 90 degrees. So delta minimum is basically 30 degrees. So now you will get full 4 marks. Yep. That's how you do it. So write down what is given, what is to be found, write down the formula, substitute, solve, and block the final answer. Full 4 marks you will get for this question. Okay, so these are the kind of questions that you can get. Moving on to the next one coming up on your screen. Okay, electromagnetic waves question. Equation is given. What is the wavelength? What is the frequency? Write the expression for the electric field. Okay, let me write down the equation properly for you. The magnetic field is given by 2 into 10 to the power minus 7. Okay, you have into sine of 0.5 into 10 to the power 3 x plus 1.5 into 10 to the power 11 t. This is in Tesla. Okay. Now if you look at this expression, you will understand that this is basically the maximum magnetic field. This is basically the angular wave number. This is basically the angular frequency, right? So from this, I think we can find everything else, whatever is required. First, let's talk about wavelength. We know that K is basically 2 pi by lambda and omega is 2 pi f. From this, I know lambda is basically 2 pi by K. So 2 pi divided by this K, which is 0.5 into 10 to the power 3. So 2 by 0.5 is 4. So into pi, and this will become 10 to the power minus 3 meters. So that is the wavelength. Everyone with me? Great. Now for the frequency. Frequency will be basically omega by 2 pi. So omega is 1.5 into 10 to the power 11 divided by 2 pi. So 1.5 is 3 by 2. 2 2s are 4. So it will become 3 by 4 and pi will be there here into 10 to the power 11 hertz. So that becomes your frequency, right? That is also done. Next important step, guys, is for field. Field will also look similar, but the maximum field will be different. And what is the formula for that? Electric field by magnetic field is basically C. So E naught will be B naught into C. B naught is basically 2 into 10 to the power minus 7 into speed of light is 3 into 10 to the power 8. 2 3s are 6. This will become into 10. So it will become 60. So E naught has come out to be 60. Now we all know electric field will be basically E naught sine kx plus omega t. Same formula. So the electric field will be this thing, 60 into sine whatever was there here, just put it as it is, 0.5 into 10 to the power 3x plus omega, which is 1.5 into 10 to the power 11 into t. That's it. That is the final answer. Obviously it will be in volts per meter, electric field, or Newton per coulomb, whichever unit you want to use. Yep, got it. Everyone, how you classified it, sir? You have to compare this with, you have to compare it with the original equation. What is the original equation, guys? I hope you remember. B is equal to B naught sine kx plus or minus omega t. So if you compare directly, you will get this is maximum field, this is angular wave number, this is angular frequency. The one which is with x is k, the one which is with time is omega. And these are standard formulas from your 11th standard. Omega is 2 pi f, k is 2 pi by lambda, standard thing. Okay, everyone? Awesomeness. Moving on to the next one. LCR circuit. This can come for easily 3 marks to 4 marks. Unit is also important. Yep, lot of people forget that unit. That's why I put over here, because usually I solve JEE problems, so I generally don't write those units and all. We are just in a hurry to get the answer correct because time is limited. So I have put up the unit. You need to constantly remind yourself unit. In the last 10 minutes, make sure you go through the entire paper, and if you missed any highlighting, blocking, units, or if something is not clear, make sure everything is proper in your paper. You will lose marks otherwise. Okay, here comes the next question. LCR circuit, frequency is given, resistance is given, capacitance is given, inductance is given, voltage is given. Find the current in the circuit. Okay, if I want to find the current, what do I need to know? Voltage is there. I need to know the impedance. Okay, I need to know the impedance. If I want to find the impedance, what do I need to know? I need to know the resistances, reactances, and all of that. So first thing will be obviously to find all these quantities. So let's find them out one by one. Let's say I find out XL. It will be omega L, which is 2 pi f into L. So it will be 2 pi into frequency is 50 by pi into inductance is 1 Henry. Pi by 50 into 2 is 100. So 100 ohms is XL. Similarly, XC is 1 by 2 pi f into C, or 1 by omega C. So it will become 1 by 2 pi into 50 by pi. Capacitance is 20 micro. So 20 into 10 to the power minus 6. Pi and pi cancels. So 50 into 2, 100. 100 into, okay, so let's do one thing. I'll just put 1 by 2 and I will have powers of 10. So this will be 10 to the power 3 and this will be 10 to the power minus 6. 1 0 here and 52 is 100. So 2 zeros plus 1 0 is 3 zeros and 10 to the power minus 6. So this will become 0.5 into, this will become 10 to the power minus 3. Goes on the top, it will become 10 to the power plus 3. So this will just become 500 ohms. Okay, this is also done. Now the last step, find the impedance. So for that, show your phasor diagram, it will be easy. always on the top you have inductive elements, capacitance on the down, resistance on the right side. So XL is basically 100, XC is basically 500, resistance 300. Using vector addition, 500 and 100 cancel out. So I am just left with only 400 here, because that will be XC minus XL, and the resistance will be over here. Resistance is basically 300 ohms. So this is because 500 is bigger than 100, so the net reactance will be capacitive. Okay, so it will be 400. 5 minus 1 is 4. Okay, now the resultant will be like this. That will be your impedance. How much will that be, guys? This is 3, this is 4. Obviously, come on guys, this will be 300 square plus 400 square. It's undoubtedly 500 ohms. So that is your impedance. Once you get the impedance, you can also find the current. Current will be voltage by that impedance. Voltage is 50, impedance is 500, 0 cancel, so 1 by 10, or basically 0.1 ampere. That is the current. Yes, Vasant. Perfect. Yes, Adarsh, you'll be getting the PDF later on. No, not 0.125, it is exactly 0.1 ampere. So good 4-mark question. Finding reactance is very important first. So I found out inductive and capacitive separately. Then I remembered the phasor diagram. Inductor is always on the top, capacitor is below, resistor is always towards the right. I solved it using vectors. This and this are opposite, so first I get rid of them. 400 and 300, the resultant is impedance. Found out the impedance. Current is voltage by effective resistance or impedance, which is 500, comes out as 0.1 ampere. Okay, moving on to the next question, coming up on your screen. Come on, let's see. What is the effect of interference pattern observed in a YDAC setup in the following cases? Interesting. Separation between the slits is decreased, screen is moved away, and width of the slits is doubled. Interesting. So beta, which is the fringe width, is lambda d by d. In the first case, separation between the slits is decreased. That means small d is lowered, so the ratio will become big, so beta will increase. So in the first case, I would just say that fringe width increases. The fringe width increases. Make sure you write this formula. Sir, but the magnitude of the wave is equal to the equally divided between magnetic and electric field. Is amplitude different from? Yes, what you are saying is energy, not amplitude. Amplitude is not divided equally. Amplitudes are completely different units. This is volts per meter, that is Tesla. Energy in joules is equally divided between electric and magnetic fields. So I think you got confused over there. Okay. For the second part, screen is moved away. So that means D is increased. So naturally beta will also increase. So for the second part also, the beta will increase only. Width of the slits are doubled. In the third case, guys, what do you think will happen? In the third case, width of the slits, not small d, width. Then intensity increases. Beta is still going to be the same. If you increase the width of the slits, the intensity of light will increase. But other than that, the fringe width will not be affected. Yep, very good. That's understood, clear. Moving on to the next one. The diagram shows bar magnet falling under gravity. Show the graph of EMF with time. What do you think is the area under this graph going to give me? Interesting question. Let's try to solve this. First of all, as it falls, the flux will change. As it falls in, what will happen? The flux will basically, let's say example, increase. Because of that, induced EMF will be created. Then what happens? Once it is inside, you will see that the flux is hardly changing in that coil. Okay, whatever field lines are coming out, going in. So once it is completely inside, almost same number of lines are going out, coming in, when it is moving also, not much is changing. When it is completely inside somewhere near the center. So you will see flux is not changing much. Whatever was there is already there. Everything is going through the coil only. Nothing new is coming. Everything is already inside. Flux is not changing much. So the induced EMF will be 0. Induced EMF will be 0. Correct? Last thing, when it comes out, as it comes out, what do you think will happen? The flux this time will reduce. So again, induced EMF will be there. But here, if the induced EMF was clockwise, what will happen to the induced EMF here? It will be anti-clockwise. Reason? Here the flux was increasing, here the flux is reducing. So here, if induced EMF is anti-clockwise, here it will be clockwise. Here if it is clockwise, here it will be anti-clockwise. So the direction will change. Hence, if I have to mark a graph of the same, if I have to make a graph of the same with time, what will I show? I'll just say, yes, the induced EMF will be there, then it will be hardly anything, and then again it will be there, and then it will go. So if once it is positive, next time it is negative, here for some time it is 0. Now the last part. What is the area enclosed by the curve going to give you? It is a very interesting thing. See guys, many people will lose marks here, but if you remember Faraday's law, it is going to be easy. EMF induced is minus d phi by dt, correct? EMF is the derivative of flux with time. So can I not say, by taking dt on the other side, minus d phi is basically plus E into dt. So integrate both sides. Think what will happen? Minus integration of d phi is integration of EMF with respect to time. So this is basically change in the flux, which is equal to, take the minus sign on the other side. Integration of EMF with time is nothing but area under EMF versus time. Exactly this area, guys. Integration of EMF with time is nothing but area under the integration. Take the minus sign over there. So what is that area going to tell you? If you don't want to keep the minus sign over there, no problem. Just keep it on this side only. No issues. It's just giving you the change in the flux. It is not giving you flux. It's giving you the change in the flux with a negative sign. That's all. Okay, keep this in mind. So the area under that graph gives you the negative change of flux. Negative change of flux. That is what it is giving you, delta. Okay, why can't it be 0? It can be 0 also. The total area can be 0. But I am assuming that maybe sometimes this might be more, sometimes this might be less. Maybe the speed changed. Okay. So things can change, right? So if the areas are not equal, total area might be some value. Okay? Yep. Great. Moving on. Okay. I think we are coming to the last few questions, guys. The voltage current characteristics of a diode are shown. What is the ratio of the forward to the reverse bias dynamic resistance? Come on. Let's see if you guys can do this. Amritini, for that question, right? You should know the Faraday's law. EMF is d phi by dt, correct? Forget the minus sign. EMF is d phi by dt. Take dt over here. So what will happen? D phi will become e dt. Integrate. Integration of d phi will be what? D phi, d phi, d phi, d phi. Total change in flux. Integration of e dt. E into dt is integration. EMF versus time. Any y versus x's integration. What does it give you? Area under the curve. So that gives you area under the curve. So the question said, what does the area depict? The area depicts this quantity. What is it? Change in flux. Okay, bacha? Clear? So this can be a good question which will probably try to hamper your full marks ambitions, right? Great, great. Moving on to this one. Now in the forward bias, use this part. This much is the change in the voltage. So the change in the voltage is how much? 0.1 volt. In that same region, what is the change in the current? Delta I. that is going to be 20 minus 10, which is 10 milliamperes. That means 10 to the power minus 3 amperes. Now we all know resistance, dynamic resistance is nothing but change in the voltage upon change in the current. This is the formula that you're going to use. So let's start with that. So in the forward bias, change in the voltage is basically 0.1. Change in the current is 10 into 10 to the power minus 3, which is 0.1 upon 10 to the power minus 2, which will make it 10 ohms. So that is the resistance in the forward bias. Similarly, in the reverse bias, what is the change in the voltage? Just check it out. It is 10. It is 10 volts. What is the current? It is 1 micro, that is 10 to the power minus 6. So this will make it 10 to the power 7 ohms. But the question is the ratio of both of them. So the forward divided by that reverse will be 10 divided by 10 raised to 7. So this will be 1 by 10 raised to 6. That is the answer. Exactly. Perfecto. How 0.1? This is given, no, this is 0.7, this is 0.8, bacha. It's clearly mentioned over here. Observe it carefully. This much is 0.7. This much is 0.8. How much will this much be in this to this part? It is obviously 0.1. Do you see 0.7 and 0.8? I don't know whether you can see that point here clearly, but there is a decimal over here. Okay, so that's how delta V is 0.1. Is that okay, bacha? Great, 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 awesome. Why is it 10 to the power minus 6? Read the question carefully. Read the question carefully. Read the graph carefully. You will understand. This is microamperes. So if you look at that change in the current, in the second case, 1 microampere is 10 to the power minus 6 amperes. That's why that minus 6 is there. Got it, Madan? So these things will make you lose marks. If you unknowingly, not look at that micro symbol, or you forget that this was milli, that's it. All the powers will get messed up. All the answers will come out to be wrong. You will lose marks. And you will consider this as a silly mistake. And you will feel very bad about it. So pay attention carefully, guys, in the exam. Never be overconfident. Always look at each and everything carefully. Okay. So one more question, guys. In the given diagram of network resistances, the name of the circuit formed is what? What is the current flowing in the arm B to D? Which law is used to find the current in the different branches of the circuit? Is that clear? If you attend all the 4 classes and follow doctor wise whatever I have told, then yes, it is possible. Otherwise not. If you just watch the classes and you're not studying at home, then it's of no use. Yes, the first answer, it is obviously going to be Wheatstone. Perfect. It's a Wheatstone's bridge circuit. That's the first answer. Second part, what is the current flowing in the arm BD? If you look at the resistances, resistance between AB upon resistance BC and resistance AD and resistance DC, I think the ratios are equal. This is basically 20, this is basically 40, this is basically 15, this is basically 30. This is in the ratio 1:2. So it is basically balanced, and hence no current. Hence there is no current in B to D. That's the second part of the answer. Okay. Which are the laws used to find the current in the branches of the circuit? The laws which are used in finding the currents, in finding whether it is balanced or not, to get this relationship are, yes, one is Kirchhoff's current law and the second one is Kirchhoff's voltage law. And you state what that law is also. Do not just write it as KCL and KVL. No, say the junction rule says that whatever currents enter in and go out, their algebraic sums of currents entering in is equal to the algebraic sum of the currents going out. So mention that statement. Same thing for KVL. The algebraic sum of the EMFs and the voltage drops across a complete loop in any circuit is always going to be 0. So mention these statements. Otherwise you will again lose marks. Half a mark, 1 mark. Don't even think of losing marks. Don't even be one bit of lazy or don't think that why should I write this? It's okay, I think I'll get marks. No, never ever hesitate to write something if the question demands. look at the marks. If it's for 4 marks, definitely you'll have to write it. 3 marks also, I think you should write it. If it's for 2 marks, then maybe not. Okay, you can just mention it as KCL and KVL. Oh, so we come to an end for this session, but I have kept some beautiful derivations for all of you. Look at this. How does the flux change by a Gaussian surface? And then derive an expression for drift speed. Capacitor is charged, then find an expression for common potential. Rutherford's experiment. Derive the angles relationship in prism. So many such derivations I have kept for all of you in these slides. You will be getting the PDF after some time in the Telegram channel. Yep, you'll be getting it. So what are you going to do now? Today? Party? Done it? Love you too, Bharat, and all the students, bacha. Yep. So what are you going to do? Party? No. You're going to give at least one mock test. Sit coolly for 3 hours and give a paper. Number 2, okay? You will see that certain things were not very clear, or certain things you will have to still revise. Go through only specific subtopics or formulas which you forgot, or definitions which you think you need to revise, or suddenly you remembered, sir, I forgot that equation. Revise all those things, write it down. Derivations, practice for 1 hour to maximum 2 hours. Today. What to do tomorrow? Tomorrow, you're just going to revise formulas again. You can watch my formula revision class. You can solve few more numericals. Go through all the definitions and underlined things again and again and again. Go through the PYQ, see where and all you made mistakes. Tomorrow, okay, do little bit of practice, maybe in the first half, but not more than that. But mainly keep reading, going through again and again, and trying to recollect whatever you have learned. Say it again and again, loudly. Or if you see that something is being forgotten, write it again and again till you get a hang of it. That's what you're going to do tomorrow. Tomorrow, don't study anything new. Don't confuse yourself by, studying a new chapter which you have not touched only, in case that is the case. Otherwise, whatever chapters you have studied should be good enough for you to get full marks, right? Great, great, great. So I hope you guys have enjoyed these classes. I'm pretty sure in these days that we have conducted. And I will try to see what I can do for maths, bacha. And all the best. Please keep going. Rock it. I am waiting for all of you on Monday to hear your feedback on how your exam went. Do let me know after the exam is over in the comments, or maybe in the post that I will be making. All the best, guys. Study well. Have a good time. Enjoy the exam and have a great lunch. Bye-bye. Hasta la vista, guys. Captain Shreyas, and I'm signing off.